Hi, it's CNT140. We're looking at Chapter 6 on cabling for wireless. So here's some of the objectives we're looking at. The big thing here we want to recognize is we know with infrastructure there's going to need to be some kind of cabling to support your access points so that users can have the mobility and freedom that they either need and or want, one of the two. So that's kind of the big picture of this chapter. So we need to remember wireless really is just replacing the patch cords, using radio frequencies for connection from the access point to your portable device, laptop, smartphone, etc. And it really is just there to get rid of the patch cord for users. Examples of wireless networks are, and I have a couple here, you think about your cellular wireless phone network. Okay, that would be one example. Wi-Fi, that's the main example we're focusing on, Wi-Fi wireless network for LANs and businesses and so forth. Bluetooth, I think a lot of us use Bluetooth for basically getting rid of the cable from phone to stereo, phone to car, etc., phone to headphones, that sort of thing. Again, cable replacement, and then WiMAX, broadband wireless. A friend of mine used a WiMAX connection in their laptop for quite a few years. They traveled for business, and there was a way they could have a consistent, broadband connection, if you will, from a provider. 802.11 Wi-Fi is probably the most important for structured cabling. Pretty much no corporate network is going to survive without some type of wireless network, because a lot of your employees have, I was going to say, a lot of people are not sitting behind a desk, so a lot of people are using a laptop, or that's their main piece of equipment or the main piece they use as they're doing their job. Over the years, the upgrades to wireless has had its issues. Most wireless now is fairly reliable and is able to provide adequate bandwidth for. For a while, wireless was not very reliable and the bandwidth was kind of meh, but it has increased over time. A lot of mobility is what's driving a lot of corporations and businesses and networks to have a robust wireless. And I have in my building typically fiber optic backbone, copper to the desktops, and then wireless for the portable devices. It could either be employee laptops kind of thing, employee tablets kind of thing, or it could be visitor wireless or guest wireless for maybe customers coming to that particular site, whether it be hospital or what it is. And that might be a specific wireless network for them just to get internet access. So here again, here's our structured cabling network that we have, main closet out to telecommunications rooms, typically fiber optic cabling connecting closets, horizontal cabling going out to outlets and workstations, horizontal cabling going out to access points, providing a connection, wireless connection for users. We have to remind people wireless is not actually wireless because on the back end, on our end, we need wiring to get to all those access points. Those access points need to connect into your network somewhere. It's really only replacing the patch cord for the user, but we need to have a cable infrastructure in the back end so that there is a connection into a network. And that is typically through copper, but some access points are now starting to use fiber connection. Some premise cabling networks are including a cellular distributed antenna system, a cellular system, if you will. We mentioned this back in, I believe, Chapter 5. About 80% of the cellular calls, originate from indoors, and cellular signals have trouble penetrating buildings. So some large buildings, convention centers, stadiums, arenas, that sort of thing, one cellular tower would not handle the volume of people in there. Could be 10,000 or 20,000 people inside of an arena or stadium. While a normal cell site can handle maybe 100 users, so we're now at 10 or 100 times the amount of people that would be connecting to that. So what gets done is your cellular provider, you kind of route a connection through your network and put a series of antennas out to connect to them. If I look here, here's another example. This is like a multi-floor, but same kind of idea. Provider connection comes in, and then you're using the distributed antenna. You're doing a series of antennas around the building to connect to that. and that allows that traffic, that kind of like, I would say not amplifying, but allowing more volume of that traffic out. Wireless offers several challenges. Good coverage and security. Those are two of the big challenges. Good coverage, I need a number of access points covering our area, a little bit overlapping, but enough to cover the area that you're trying to do. And I normally need to have some kind of plan for my access points. I'm showing you here the slight overlap, but I also need to worry about the channels that my access points are using. I need a plan, and that's what they're showing you around the edges here, what channel each of the access points are going to use. So that would be my plan, and there is what your plan is, but the actual might look more like this because of walls, ceilings, posts, iron beam, steel beams in the ceiling, maybe metal studs in the wall, concrete block walls. They all affect your signal. So that might be my plan, but the reality is some of them might need to move around to accommodate the building structure to get the coverage you need. Security is another challenge. Any AP is a potential spot for users to get access to your network. So there needs to be, that wireless network needs to be connected into a network that's secured and or separate from your network. Might need to be just secured, VLANs and those sorts of things, or it might actually be a separate side network, if you will, for those users that they don't have a direct connection to corporate servers, that kind of stuff. So that has to be thought about. I can't just connect it to any switch. I might need a plan, a separate switch. I might even need to implement controllers, wireless controllers. And the wireless controllers, the access points connect into, and these are now monitoring and managing that wireless traffic and can even look out for rogue access points and shut them down. Somebody tries to plug one in an office. Here they can, I try to plug one in my office. The controller can be like, I don't know what that is, and not allow that signal traffic through. Wireless standards, the 802.11 Wi-Fi or wireless fidelity is probably the wireless, that is probably the standard we know. Unlike some of the other ones we mentioned earlier. This is what we think of as wireless or wireless network. With this, originally 802.11b came along, and then A and so forth. So initially, our wireless standards and coverage and so forth were kind of spotty, kind of like limited bandwidth, etc. But as standards progressed, we were getting better connection and better bandwidth, more reliable connection and better bandwidth. Wi-Fi is what most people are used to, and now laptops, if you think about it, many laptops come with a wireless connection. For the longest time, your laptop came with no connection, and then they came with a wired network card, and then eventually they started coming with a wired card and a wireless card, and now most modern laptops don't have the wired network card, but just have the wireless. So it has kind of progressed where most laptops now come with that wireless built in, but not even the wired connection. Your 802.11 standards overseen by IEEE. I have a link here to the standards that might be handy for reference. And I tried to create a table here that's kind of summarizes a lot of the aspects that the chapter talked about. I tried to put a little bit more usable data in. If I look down here to the left, they actually start reference these by Wi-Fi 1, Wi-Fi 2, and so forth. Very first networks that anybody might have used wireless would be 802.11b. That's called Wi-Fi 1. And then here I tried to put in here the approximate bandwidth that you would get, the frequencies it's using, and the approximate indoor-outdoor range of these. Try to make this as a good resource for you, but again, you can get a lot of that from here, going right there to look up anything that has progresses down the line. 802.15 is our Bluetooth standard, and most of us recognize this as your short distance cable replacement. And that is your, as I say, smartphone to headphones, smartphone to maybe a stereo in your house, smartphone to the car, that kind of connection, short distance wireless connection. That's what that is pretty handy for. WiMAX, this one, might not be too familiar to some people, but for a number of people, like my friend that actually traveled, he was a television engineer and would travel with a television production truck all over the country. Since he was rarely at home, he got a Wi-Fi WiMAX connection for his laptop. So wherever he was, as long as he had a cellular signal, if you will, he had an internet connection. And that was an interesting use. That was one of the first times I saw like that. That was an interesting use for that, and that allowed them to always have that connection. That's your 802.16. And I think I have a sample here where you have the service provider with your towers that can provide you a connection to your house, or in his case, it was just his laptop connecting to. That worked well for his scenario. Cellular phone network, this is probably your largest wireless network. That's kind of probably the first wireless network that people might have encountered, even before wireless in your house. We said before about, the large volume of connections, calls are originating from inside. So a lot of facilities have this. It's basically a cellular, kind of like cellular antenna into your facility. And those antennas around would be able to route that cellular traffic out through and to the cellular network. Some of your larger places, conferences and arenas and stadiums and so forth, have these built in to handle the volume. And that's your distributed antenna system that we said here. Right here, distributed antenna system that we looked at earlier. Wireless is really only wireless for the final user, as we said. Cell towers that you see everywhere are generally connected to fiber optics to get back to the provider. Wi-Fi access points are part of structured cabling. Even convention centers using the distributed antenna system, there's still cabling to connect those antennas back to that equipment. So really it's only for the end user that we don't have the wired connection. But all this infrastructure needs to be here for the access point to connect, either copper or fiber. And if you have the distributed antenna system, there is still cabling here out to these devices and antennas and so forth. So wireless is really not wireless, really only for the end user. So now as we look at access points, we do need to connect them in. So if I look at a logical map of a network, and this probably looks similar to network you built for 120, my access points are connecting into the switch. Well, there has to be a connection there. And typically what's going to happen is those access points will get installed in the ceiling of a work area, maybe in the hallway, maybe in the work area. And it's this type of access point that's connecting in. And on the back, there actually is an RJ45, a copper connection. Some of the newer ones come with fiber optic connection. But that is going to plug into an outlet that we're installing above the ceiling. So every so often, above the ceiling, we're going to install an outlet that we can plug our access points into. So there has to be a cable structure for them. And then there's even hardware to mount the access points up in the ceiling. Some of them even have covers that go over them to kind of put them out of sight, out of mind. There's another style here as well. Okay, so those access points do need to be cabled in. And they talk about, okay, while there should be an access point in a business can handle maybe 15, 20 users. So I might need, in a house, that would be enough. One access point in your house would be enough. Small business might be enough. But as I start getting into maybe a larger house or even a small business, I might have too many connections there. I might need a second access point. So the rule of thumb they talk about is about the access point can cover about 300 feet indoors, maybe substantially more outdoors because there's not much blocking the signal, but it's going to depend on anything, walls and so forth in the building. So a single access point can handle a few users, but as I get my user number higher or my distance bigger, I might need to start putting more access points in. And we'll come back to that in the next podcast.